So after creating the workbench and after setting sheet metal parameter, you can create first wall, and after that you can create secondary walls and bends. Then creating sheet metal features like cutouts, holes, flanges, and stampings can be done on the secondary walls. And then the deliverable drawings, like converting it into DXF files or creating additional patterns, are all the next steps. So this is a general methodology for creating a sheet metal part in CATIA. Not only in CATIA, any of the design software, like in any platform. Okay. So next thing, so we have view modes. Like view managements is there. I'll be explaining this view modes in CATIA. View management is there, fold, unfold is there, multi-view is there. Let me discuss all these things on the CATIA screen. Before that, we are going for the command called recognize. So there is a command called recognize in walls. Okay. So we'll see what is recognize now. Okay. I am into the CATIA workbench. Go to start mechanical design, generative sheet metal design. Here select part, click OK, so that you will be entering into the sheet metal workbench. In the sheet metal workbench, set the sheet metal parameters. Like I'm not setting the sheet metal parameter now because I'm going to create a part, which means recognize. The purpose of recognize command is to recognize a part body or a step file. When you import a step file or when you import a part file into a sheet metal, it cannot be like unfolded, because since it is a since it is in part form, or else since it is in step form, you cannot able to fold or unfold those kind of model. To make those kind of models into a sheet metal, you need to use a recognize command. Is that clear? Is that clear about recognize? I repeat one more time. Recognize command is used to convert a normal part file or a step file which you are importing into a sheet metal design, and then you want to make it into a sheet metal object. So let me go into the example. I'm going to create a part body here. Uh, Go to insert, like go to body, in part body, go to sketch, select the part body and select the plane, go to sketch. I'm creating a part here. So I'm creating a sketch now. So go into start mechanical design, part design. So if it is a V6 version, so please remember this. If it is a V6 version, we can able to click here, like on this setting. So we have part design settings, sketch. We can able to shift from one environment to another environment from here. So, but in case of V5, we don't have that option. We have to go in this manner only: start mechanical design, part design. So here I'm giving part. Since it is a line sketch, it is showing it is a open profile. Click yes, and here click tick, and then give mirrored extent and give dimension. Like I'm giving 100 mm. Sorry, 100 mm. Click OK. See, this is a part file. I repeat one more time. Since I have drawn the line sketch as an open profile, when you open into a part body, it will show some warnings, which means the sketch is open. But still, you can create pad when you are enabling thicken option. When you're enabling thicken option, the open sketch can be padded up. So I have enabled the thicken option, then I have padded it into mirror of 100 mm. Okay, now I'm shifting back to generative sheet metal design. So now we are in the generative sheet metal design. And remember one thing, when you go into this pad, I edit again. See here the thickness mentioned here is 1 mm. Okay, remember this. This is more important. Whatever thickness you are giving on the part body should be maintained on the sheet metal parameter there. So here the thickness is 1 mm. So now go back to the sheet metal design, generative sheet metal. So we are in the sheet metal. In the sheet metal parameter, give the thickness as 1 mm. See here, I have given the thickness for the pad 1 mm there, and I am giving 1 mm thickness here also for the sheet metal parameter. Click OK. Now, when you try to unfold it, see here, this is a part body now. When I am unfolding it, it will get hidden. Like the whole entire body will be hidden. I repeat one more time. When you are trying to unfold or fold the part body, it will get hidden. But so to make it as a sheet metal part, we need to go into recognize command. In recognize, since it is a simple geometry, we can directly select the wall and click OK. So the wall will be defined. But if in case if it is a complex body, you want to select which is the bend, which is your edge, which is the stamp. You need to select on each and everything, and you need to recognize. It is something like remembering the feature. So when you save your file as a IGS file or step file, you will not be having that file history. To bring back that file history, we'll be using this kind of recognize option. Is that clear? So since this is a simple object, we can directly select only the wall. See, I have selected this as a wall and click OK. Now, as you can see under pad option, you have this recognize feature. So this recognize feature determines that this is a sheet metal object now. So now I'm creating secondary sheet metal parts like hole. Remember, you can able to create secondary features only on the primary wall. So since I have made this part body as a sheet metal, I can able to create the secondary features. I have created a hole here, and now I'm creating a edge on wall. So now if I'm trying to unfold, it will unfold and fold. So this is what recognize option. Are you clear with recognize, everyone? Or should I need to repeat again? Are you clear with recognize? Okay, I'll repeat one more time. Okay. So recognize option is something like remembering the feature history. For example, if you have a step file or if you have your part body into a sheet metal. So you all know that sheet metal is a uniform thickness, and when you are creating a part body, it might be of having variable thickness. So that you need to maintain same thickness on the pad and also same sheet metal parameter thickness on the sheet metal workbench also. So what I'm doing is, see here, I'm deleting all the features which I have done. I'm going to repeat this again. Please listen carefully. So we are in the sheet metal. So we are in the sheet metal workbench. In sheet metal workbench, I'm going into insert command, insert a body, which means a part body. So when you click on insert body, you will get a body option here. By selecting the body option and selecting plane and sketcher, you will be moving into the sketcher profile. Create whatever sketch you want to recognize as a sheet metal. This is a part now which I'm creating. So there is a difference between a part and a sheet metal object, because when you are using a part, the part body has its own stiffness, so it cannot be folded or unfolded. It will be something like a constant one. So that is why we need to recognize it into a sheet metal, because only sheet metal parts can be folded and unfolded, not the part body. So what I'm doing is going into part design. I'm creating this line profile into a part body. So you can able to create a part body. Exit. 1 minute. Start mechanical design, generative shape design. Insert a body. Create the sketch. And remember, there is no limits for creating sketches. Like it might be any type of sketch, but only thing is you need to remember everything. go to start mechanical design, part design, and here go to pad. Since it is an open profile, it will be asking like it is an open profile, you cannot pad. But if you are enabling thicken option, so with the help of thicken option, you can able to create pad for open profile also. Specify any length which you want. I'm specifying 100. And in the thicken option, you have thickness, the thin pad thickness option. I'm specifying the thickness for this object, which means the line profile will have 1 mm thickness on both sides. So click 1 mm here, and the part body is formed now. Now I'm moving into generative sheet metal. So we are in generative sheet metal, and we need to specify the same thickness which we have given on the part body. So there we have specified as 1 mm. So I'm specifying here also as 1 mm. Bend radius is 4 mm. Click OK. And now see, this is a part body. So if you are trying to fold and unfold, see, I haven't converted it into a sheet metal now. Since it is a part body, when you are selecting fold and unfold, so it will be hidden. The entire part will not be unfolded because it is a part body. So to make it as a sheet metal, we need to use option called recognize. So if the object or if the model which is drawn is very simple, you can able to specify only the primary wall. You can specify selecting any face and select that face as a primary wall. Like I'm selecting this face as a primary wall. And then if you are creating a complex part body, then you want to specify which is the bend, which is the edge to bend. And if you have any stamp, you have to specify this is the stamp. All these things you want to select. So in this list, after selecting everything, click OK. After clicking OK, when you go into the body option, you will have this recognize option under the pad command. So that this recognize means that this padded object is being converted into sheet metal. Now, uh, do you remember that secondary walls can be created only on the primary walls? Since I have made this as a sheet metal, I can able to generate my secondary features, something like a hole and edge on wall. Yes, edge on wall. So I'm creating edges on wall and all these features now. See, the sheet metal part is created now. Now if I unfold it, it will unfold. So this is what recognize unfold and fold. And now you might have the question that what happens if I change the thickness in the pad option. See here, if I'm going to pad again, and I'm changing the thickness to 2 mm. See here, it will show error. Like even if you update, so it will show an error called a permanent restriction was encountered because there is a varied thickness between the padded object and the sheet metal parameter. So if you change the sheet metal parameter into the same thickness, say 2 mm, and if update, so it will become the sheet metal part again. Is that clear? Is that clear? Yes. Okay. So this is what recognize option. So recognize means if you don't have a part file, or sorry, if you don't have a sheet metal file, if you have only step file or part body, you can still convert it into a sheet metal object for additional generation of sheet metal tools. That is what recognize. Now let's go into the next option. I'm deleting this. Let's go into the next option. Sheet metal parameter 2 mm. So the next option is corner reliefs. So we have discussed about this relief yesterday itself. Like these are the bend extremities which is used for the sheet metal. So to avoid the overlapping or to avoid mismatches between two or three faces. So we'll discuss what is how to apply corner relief and what are all the various corner reliefs that are available in CATIA. So for that, for creating a corner relief, you must have a primary wall and a secondary wall. So I'm going into a sketch and I'm creating a primary wall now. If the part body has different thickness, will it recognize? Yes, of course, it will recognize. So that is what I told. If it has a variable thickness, you need to specify that as a primary wall. The the face which has the like variable thickness, that should be a primary wall, and remaining other will be the secondary walls. So whatever part body you are importing, or whatever part body if you are inserting, you need to specify the variable thickness as a primary object. For example, if all other faces have 2 mm thickness and one particular face has 4 mm thickness, you want to make that 4 mm thickness into a primary wall. So now I'm creating a primary wall now. X wall. Then I'm generating secondary walls right here. Secondary walls. So this is my secondary wall. So as you can see, by default, it will be having some corner reliefs at the corners. Can you able to see? So while generating itself, it will create some corner reliefs. So if I want to change the corner relief, I want to keep it in a unfolded view. Remember, this is more important. So to apply corner relief, you must be having, you must have keep the model in the unfolded view. Is that clear? So I'm going into corner relief. Select the two faces where you want corner relief. Say these two things. Now as you can see, the circular face is happening. As you can see a circular section here. Since the type of relief selected here is circular, there is a circular section here, and provide the radius of your relief, say 8 mm or 8 mm or 4 mm, and then click preview, then click OK. See here, the corner relief has been changed from square to a circular section. So I repeat one more time. So to use or to apply corner relief, you must have a primary wall and you must have a secondary wall. And after having the primary and secondary wall, you must be in the unfolded view. So you cannot able to apply relief on a folded view. Remember, you have to keep your sheet metal component on an unfolded view, then select the particular faces. Go into corner relief. It will ask for supports. So I'm selecting two supports, and I am selecting the type as circular and mention what is the radius, say 8 mm or 10 mm, whatever it might be, and then click OK, so that the relief will be created. So when you unfold it, you can able to see the circular corner relief. So the other side it is different and this side is different. In the similar way, you can able to add other additional reliefs, something like go into corner relief again, select the two faces where you want the relief, and then change the type, like either it's square or user profile. If you have your own profile, you can use user profile. Square, so it is already in square, so change the length or length of the square, say 12 mm or 16 mm. Click OK, so that you will have that type of relief. Then fold it and unfold it. When you are folding it, you can able to see square relief at this side and circular relief at this side. Is that clear? Is it clear with corner relief, or should I need to repeat again? Everyone? Okay, fine. So this is how we need to apply corner reliefs, and then we have other additional modification tools like corners, chamfers. These things we would have discussed in the part modeling itself, since but still we have some difference in the corner and chamfer for sheet metal. I'll let you know what is that difference. So what I'm doing is I'm going into corners. In corner, it will ask for edge selection. You can select the edge, uh, but here the selection of edges, it should be selecting all. You cannot able to pick one particular edge, since it is a sheet metal. Everywhere it should be same. So mention the radius and click OK, so that corners will be created on all corners. See here. So I repeat one more time. In corners, you need to select all the convex, either all convex edges or all concave edges at a single stretch. So if I can able to give radius separately for concave edges, and I can able to give separately for convex edges also. And since this is a checkbox, so if it is a radio type button, you know it is something like either one at a time, but here you can do two at a time or one at a time. So that is a, specialty of this corner option. In case of part modeling, if you are specifying corner, you can able to pick one particular edge and you can specify radius. But in case of sheet metal, you need to select all, and see here, all the edges which doesn't have the corners will be selected, and specify a common radius so that it will be cornered on all the sides with same radius. Is that clear? Okay, the next thing is chamfer. It is similar to the corner option. So here also, yeah, you need to like, uh, the convex edges should be selected, and on the convex edges you can specify the propagation, either whether if you want the chamfer as a tangency mode or a minimal mode, you can specify. And then after selecting, here you have different types, like there are two types for chamfer. In Creo you might have seen like many types for chamfer, but in case of sheet metal you have only two types. One is either specifying two lengths or by specifying one length and one angle. So let me select two length. I'm specifying 2 mm on one side and 1 mm on one side, then click OK. So if you want to reverse the side of chamfer, you can select reverse, click OK, so that you will get chamfer. So this is what the use of corners and chamfers. Generally we don't use corners and chamfers more often, but still we need to know about all these things. And let's go into the next toolbar called bending. Are you clear with corner and chamfer? So if you have any doubt, like let me know by at last, I'll explain again. Okay, now we have one more option pending here, that is surface stamp. So we'll discuss this surface stamp after discussing this bending options. Okay, first we'll go into the bending toolbar, then at last we'll discuss the stamping option. Okay, now in bending you can able to see two types. One is a normal bend and another one is a conical bend. I hope many of them would have not tried this conical bend. So we'll discuss both the types today. See here, we have two types, normal bend, conical bend. So for that, you need to have a primary wall. Go to wall, wall on edge. Here, disable this with bend. Okay, so that there will be no bend at all. So I repeat one more time. I'm going to create a secondary wall with no bend. With see here, I'm disabling this bend so that it will be on the surface. See here, this is how it will look like. So it doesn't have a bend. Is that clear? It doesn't have a bend. Now go to bend option. In the bend option, specify the two supports where you want the bend, or else click preview. When you click preview, you can able to see a bend is created on this wall. So this is what bend. So if you don't have a bend for primary and secondary walls, you can able to create bend between them. And remember, the radius used for this bend is constant, which you specify on the sheet metal parameter initially. So the radius which you are specifying on the sheet metal parameter will be considered for this bend. Okay, and click OK, so that the bend is created. So this is what normal bend. So now I'm deleting this normal bend again. Cylindrical bend, delete. Now we have conical bend. So conical bend is nothing but which will have a variety, like variable radius. So you can able to specify different radius there. So I'm going into conical bend. Select the two supports in the same way. Specify two radius, like 2 mm in one side and 6 mm in one side. So here you can able to specify your own radius value, because since it is a conical bend. So this is conical bend. Is that clear? I'll repeat one more time for your understanding because these are all very important. So if you have a primary and secondary walls which doesn't have bends or which is created like in a manual way, so that the manual bends can be created using bending option. So in bending we have two types, one is normal bend and one is conical bend. So using normal bend you need to specify two supports, uh, and the radius which is the radius will be considered from the sheet metal parameter which you have given initially. Click OK so that bend will be created. So this is with equal radius. So if you want to create a conical bend, select more, which means what you are trying to say, Krishnakant. In normal bend, okay, you are asking about the more option. Okay, see here, when you go into more, you will have extremities. This extremities will be there at all the end. Extremities is nothing but the relief which we have discussed. Okay, so these extremities can be given, and bend allowance factor, if you want to vary k factor, see, right click here, edit on the k factor, you can able to edit the value. So that is why the more option is present. So if you want to change the sheet metal parameter at any instant, you can use that more option. Is that clear, Krishnakant? Okay, fine. So now here, to create conical bend, delete this. Conical bend will have multiple radius. Select the two supports, specify what is your radius, like 2 mm and 6 mm or 8 mm, and click OK. So you will get the conical bend. Fold, unfold. So after creating conical bend, you can fold and unfold. So this is what bend type. The next type is bend from flat. Bend from flat means if you have a flat primary wall, you can able to bend it with a straight line. Wherever you want to bend, there you can bend it with a straight line. See here, now we are having a primary wall. I need to bend it at particular location, so that I'm going into sketch, go to sketch, line. I'm creating a line randomly at some location. Exit workbench, go to bend from flat. The line which you have created will be selected, and then you can specify the angle at which you want to bend, 75, and click OK, so that you will have the bend from the line which you have created. So this is bend from flat. So if you need to create a bend on the primary wall at any random location, you have to use bend from flat. So for that you must have a straight line. See here, a straight line at any random location. Go to bend from flat. The line will be defaultly selected. Specify the angle in which you want to bend, and then click OK, so that the bend will be created. Okay. The next thing is folding and unfolding. I'll explain this folding and unfolding with this example itself. When you go for unfolding, first option is unfolding. So you need to specify, this is similar to recognize option. You need to specify which face is your reference face. I need to select this as my reference face, and unfolding face, from where you want to unfold. So from this, can we able to control the side? Yes, we can able to control the side. See here. Go to the line profile here. Here you have fixed wall option, the wall from vertex. Here you need to change the wall from vertex, then the direction will be shifted. The wall from vertex, you need to select some other, which side, which vertex side you want to bend. So there is a fixed point here that is considered. If you want to change, you need to select this sided wall. So the vertex point is used for for controlling the side. Okay. Now we'll go into the folding or unfolding option. Go to unfold, and in unfold specify your reference face, and you need to specify the unfolding faces. Like from this face, from this cylindrical face, I need to unfold. This is the unfolding portion. click OK. So it will be unfolded. In the similar way, you have folding. In folding, you need to specify the reference face. See, I am selecting this as my reference face, and folding face, in which location you need to fold. I am selecting this. So from this location, it should be folded, and click OK. Now it will be folded again. Is that clear? Are you clear with folding and unfolding? It is similar to recognize. In recognize, it will recognize a part body into a sheet metal, but in folding and unfolding, you are just saying the GUI that from this location you need to unfold it. From this location you need to fold it. So we need to select those regions. Okay, is that clear, everyone?
Sir, excuse me, sir.
Tell me, Vidu.
Sir, if we create a spline instead of that
No,
line, can we
no,
bend?
no, we cannot. We cannot able to bend it because you need a straight line. The mandatory thing is a straight line. Okay.
Okay, sir.
Okay.
Sir, for example, if you take the common rail for that,
If you take a
we take that common rail for vehicle assembly, that time
okay,
how do they create that bend, sir, for sheet metal?
they'll create it in a part. They'll create it in a part and bring it back into the sheet metal. They'll not create it in inside sheet metal itself. Okay.
I didn't get you, sir.
They will create those kind of structures in part modeling and then bring it back into the sheet metal. They'll not create in sheet metal itself.
Okay, sir.
Okay. Then
Sir,
we have yes, Krishnakant.
sir,
Hmm.
what if we draw a line in between the on the plane, like do not extending the plane, the
Do
wall.
not do not I couldn't get you.
What if you draw a line on the one plane, sir,
Okay,
one wall.
I'm selecting a plane now.
Hmm.
I'm having only primary wall now. So I'm
Hmm.
selecting this face,
Hmm.
going into sketch. So here what you are trying to say? Line, create a line, huh?
Please create a line,
Hmm.
not crossing the body.
Not crossing away from the body. Huh?
No, sir. In bit on the body.
In an inclined manner. You are saying about inclined manner.
No, sir. No, sir. From the origin to that H.
Origin to the here like this.
Not to the outside the
Half,
body, inside the body.
half.
Half up to the origin.
No, if you are having a half up to the origin, it will not be bended. Like you are saying like this only, na? Like this, na?
Huh.
So it will not be
Yes,
bended.
sir.
It will not be bended. See, let me go back. And if you go to bend from flat, it will be considered the entire length only. See, since if it is an open section, for example, if you have provided a cutout or if you have cutted the section, from there you can bend. Okay, Krishnakant.
Yes, sir.
Since if you have created a cutout, something like this, see here, if I have a cutout section like this, and here I have another profile. So if you have that kind of structure can be done only on the secondary parameter. So if I have created another vertical plane here, there I can able to bend with a small line. So only the entire length will be considered for bend from flat. It will not consider half of the length. Even if you draw half line section, it will be considered the whole entire length. Okay. So the next thing we have discussed wall on edge yesterday, like a wall on edge. So in wall on edge, you have the relimiter option. Have you tried this relimitation option? Have you tried yesterday? So we'll see what is that relimitation option now. Now I'm going into sketch here. I tried. Okay. Rahul, do you got that relimitation? Okay. I'll repeat with an example now. So go into, I didn't get tangent to surface. Okay, fine. We'll discuss now. So I'm going into surface design. See here, wireframe and surface. In wireframe and surface, select the face. And here I'm creating a straight line at this side and a spline at this side. Okay. Exit and go to extrude. Select the two profiles and extrude on both side direction, like mirror direction. Click OK. Now so you have created a surface now. Go to sheet metal now. Go to sheet metal, generative sheet metal. Go to wall on edge, and select this wall so that you will get the entire wall now. In the extremities, go to left limit and select this as your left limit, and then in the right limit, select this as your right limit. Sorry, I have selected in a wrong way. Left and this and right. Select your left. This is your left limit. I need to create it in a two different sketch. I have created as a single sketch. That is why it is coming like that. I'll go back to create two extrudes now, since it should be two different things to select. Let me go back. I'll delete one sketch now. Delete, exit, extrude, update, so that you will have this thing here, and go to surface design again. See, the mistake I have done is I have drawn two lines on the same sketch. So that is why it cannot be selected as a relimitation. Relimitation means the start and end point. So it should be two different things. So now I am creating the secondary extrude. Extrude, click OK. So now we have two extrudes here. Go to start mechanical design, generative sheet metal. Go to wall on edge. Select the edge so that the wall will be created on entire edge, and go to extremities and select the relimitation, extrude 1, and then relimitation 2, extrude 2. And then so in between you have the left and right orientation, the gap to be filled. Here you can give the value 100. Let me go with one limit now, 10. We have some problem with this relimitation. Just hold on. So we have created two surface. Then go to we are going delete spline and make line. No. Like we even if it is having a spline command, we can able to create the relimitation. Go to extremities and select. First of all, specify the edge, and there, and then on the relimitation, left. This is your left limit, and then select your right limit. So it is saying that the specified limit must be defined a closed wall profile. Okay. So let me explain with one limit now, and I'll explain this two limits when we are discussing the example. Okay, so I'm selecting only one limit. Uh, so I'm selecting this as a right limit. So when you have this relimitation option, you can able to the idea is nothing but you can able to relimit your wall. So it cannot be it will be generally entire length, like here from this start end to the this end point. The idea of this limitation is you can able to stop it with any other specified location. So that is the main idea. And if you have two limits, you can able to stop it in between, like from here to here. So that is the main idea. Is that clear? And now if you want to offset it with some distance from the selected length, say 10 mm, from the selected edge, it will be offsetted to 10 mm. And if you increase the offsetted length, it will extend. So this is the idea. Is that clear? So the main idea of this relimitation is we can able to control the wall on edge, like wherever up to which length we want, up to which distance we want, we can control. Okay, and we'll try this two limit at last. So I want to say about these things to you today. That is why I came to wall on edge again. Now we have one more option left in bending, that is point on curve mapping. Since point on curve mapping itself is a huge topic, we'll cover that in a single day. Like point on curve mapping is a new technique which is created on V5 V6 only. We have this option in V5 V6 only, and so we'll discuss this point on curve mapping on tomorrow's session. And now we'll go into the stamp option. Like we have different types of stamps. So stamp is nothing but if you want to create a stamp on primary walls, you can create stamps. So first type is surface stamp. I'm sorry. Go to stamp. Here we have multiple options here. Since we have different types of stamps, I'll explain one or two types of stamps. You try all the other types of stamps and let me know if you have a difficulty with any other type of stamp. So here we must have a profile. So we must have any profile. Here go to profile section, go to sketch, select the primary wall, and there create a sketch there. See, I'm creating a sketch here, and specify the radius. Like radius is the bends. When it is getting stamped, it must have a radius at all side, so that you can specify the radius. And if you want to make it as a tapper, you can give the angle here. Like instead of 90, if you are giving angle, the tapered angle will be occurring. Height, you can mention the height of stamp, how much height it should be stamped. Let's say 6 mm. So see here, click preview, and you can able to see the stamp. This is surface stamp. So whatever sketch you are drawing, that will be stamped into the sheet metal. Is that clear? So you can able to change the radius, and you can able to change the height, angle, all these things. This half ps command, so half ps is nothing but it will be on either half of the location, like only half ps. uh, Say the half ps is nothing but radius will not be there, only the height will be there. That is half ps. So if you are disabling the half PS, you can able to give the radius value, but in case of half PS you cannot able to give the radius value. And here you have two types. One is the upward sketch and another one is the downward sketch. You can able to create stamps either upward or else downward. Okay, so this is the type of stamps. So we have two types of stamps. So if you want to open one particular edge, you can select open one particular edge and click preview, so that when you see at the bottom you can see that is a opened section there. See, if I select that opened section, see here it is opening at the bottom. So for your level of understanding, I'm increasing the length to height to 6 mm. So now you can see one side is open. This is the purpose of opening edges. So you can able to create stamps like this. Is that clear with surface stamp? Is it clear? So for creating stamp, you must have a profile. So you must have any profile to create stamp, and we'll go to stamps again. There are different types of stamps: bead, curve stamp. Curve stamp is an open profile. If you have any open profile, you can create stamps there. Flanged cutout. Flanged cutout is something like pocket command. See here, go to profile, select the plane and create a circle here. Go to circle and then exit from the workbench. And when you click preview, specify the radius. Like I'm specifying the radius of the stamp as 3 mm and height I'm specifying it as 6 mm, and then click preview so that it will be open. So this is the flanged cutout. So it is something like stamp, but it is open at the bottom, so that is known as flanged cutout. Okay, is that clear? And we have lower. Lower is something like similar to the open profile. You can able to open one particular direction. See here, create a sketch there, specify the radius, angle. Here you have two angles actually. Specify angles if you want, 6 mm, and mention which side that should be open, and then click preview. See here, this is similar to the first surface stamp. You have this open line option in many of the stamping options. So these are all the options which is used in lower. So the next thing is flanged hole. You know what is flanged hole, circular stamp. The next important thing is stiffening rib. We'll see how to create a stiffening rib now. Can we able to make angle with lower? Angle with lower, which means yes, you have the angle na, 0 degree to 90 degree. See, these are the angle A1. This is the angle for A1 and this is the angle for A2. So if you are specifying two different angles for A1 and A2, you can able to create lower like this. So that is why you have two different angles, A1 and A2 here. Now we'll go to the stiffening rib. For stiffening rib, you know what is stiffener in part. It will create support between the horizontal and vertical component. The same option here. So I'm creating a wall on edge. Go back to wall on edge with bend. Okay. So here, go to stiffening rib, and in stiffening rib you need to specify the circular face where you need to create the stiffening rib. So specify the radius and like angle and length, and then click OK, so that you will get a stiffening rib here, this support. And you can able to change the position anywhere else. Like if you are creating create a point, normal point here. See here, I'm creating a point on this surface. Click OK. So there is a point on the surface. Go to stiffening rib, select that particular point, like this surface and that particular point, and you will get a stiffening rib at that particular point. So you can create stiffening rib at any location you want. Is that clear with stiffening rib? Now, dowel is something like a punch, a circular punch. It will have only diameter. When you click dowel, it is something like this one, uh, a circular punch. What, Seduji? You have any other doubts, Seduji? Stiffening rib pattern. Yeah, you can pattern stiffening rib also. You have, see here, you have the pattern option, rectangular pattern. You can pattern. But remember, for creating stiffening rib, you must select the cylindrical faces, like the bend only. Okay, you should not select any other faces. It should be the cylindrical selection. Is it clear? And at last, okay. And at last, we go to stamp option, user stamp. That is nothing but punch and die. So we'll see one example for the stamp option here. You can able to create your own stamp. Like for that, the stamp should be in the part body. It in case of creating a stamp, you must have a part body there. So I'm editing this primary wall sketch for my convenience. I'm providing dimension for it, say 200, and I'm giving dimension here also, say 200 again. Click OK, and now exit. So I have a primary wall. So whenever you edit a sheet metal, you need to click update option. The update option will be available in at the bottom, or else it will be available under edit menu. Go to edit, there you will have update. Okay, or else the shortcut of update will be Ctrl plus U. And now what I'm doing is I'm inserting a body, a part body, and then select body and one particular face. Go to sketch. There I'm creating a part, a cylinder. Exit. Go to start, mechanical design, part design, pad. I'm padding on both side direction with 50 mm. Okay, so this is a part body and this is a sheet metal. Okay, now I'm selecting one particular face, again going into sketch, and I'm creating a hole here, pocket 50 mm. Okay, so I have created a solid like this. Now go back to the sheet metal, generative sheet metal design, and there go to stamp, user stamp. Okay, in the stamp option, it will ask it is having a sheet metal feature can't be inserted here. Click yes. Since now you need to select which is your sheet metal part. First, remember, you need to select your sheet metal part. Then you must select which is the part that is going to be punched. So I'm selecting this cylindrical faces, and remember to keep position on context. You must enable this position on context so that it will stay in the original position. I repeat one more time, you must always enable this position on context, then only it will be available on the position, else it will shift its position. Okay, and after selecting the position, you need to specify which faces it should be open, from which space you want to create punch. In the face for opening, I'm selecting this face and the inside circular face, and then click OK. So you will get a punch. So I repeat one more time, user stamp, click user stamp, click the circular face, select the sheet metal face, and then select the region for punch and enable position on context. Then on faces for opening, select this face and the circular face inside. Okay, and then click preview. click OK. So you will have the user defined punch. So this is how you can able to create punch. Is that clear? So in the same geometry, you can able to switch the punch based upon the selection. If you are selecting some other face to be opened, the punch shape will be different. Is that clear? Are you clear with the user stamp? Is it clear with the user stamp? Are you clear, or should I need to repeat again? Guys, are you clear with the punch, or should I need to repeat again? Okay, you need clear. Fine, fine. So I'll do it anyhow. I'll do it one more time, fast, like this time. So this is how you create a user-defined stamp, and there are various examples that are available in net. You can also practice with those kind of examples also. And so with this, we'll finish off today's session. And we have some of the option that is left. That is point on curve mapping. And we have in stamp itself, we have one more option called punch and die. So a punch and die, point on curve mapping, and then we have this translation features like mirror, pattern, sheet metal pattern, and translation. All these are left. Only these things are left in sheet metal. So yeah. சொல்லுங்க சேதிஜி.
அது பாக்கெட் பண்ணலமா?
ஆமா.
அது என்னமா யூஸ்?
புரியல புரியல புரியல.
Why you done that pocket?
Like
there is no use of that.
No use of pocket da. Actually, for in the same example, if you are selecting the different face, the pocket also can be created as a stamp. Okay.
This case, there is nothing.
In this case, there is no use of that pocket. I just created a secondary an example, just an example. Even if you have a circular hole, if you are selecting that particular face, that hole will not be considered. For that case, I have created that hole. Is that clear? So while selecting the face, if you are selecting the particular face to be opened, and that even if the part body has a circular object, it will not be considered.
Okay, if I don't want that opening on the other side, only a small portion to be extended.
If you want to shift the opening, you have to select the different opening faces. If you are selecting different opening faces, the stamp will be of different shape.
Okay, okay. I will try it.
Okay. And so we have one more option left, that is punch and die. In user defined stamp, you have punch and die. So punch and die option we'll discuss tomorrow, and then we'll discuss this point on curve mapping tomorrow. And then we have one more option called check overlapping. So if you have overlapping between sheet metal object, we can able to check the overlapping. These things we'll discuss tomorrow. So I hope everyone is clear with today's session. So if you have any other doubt, you can ask me in private, like you can mail me, so that I'll clarify your doubts. Okay. So thank you. Bye. I'm exiting the session, and we'll discuss the remaining the application of sheet metal with some examples like creating how to create CPU, how to create a kitchen sink, those kind of things using sheet metal. We'll discuss those kind of models in sheet metal tomorrow. So thank you. Bye.